dreaming, learning during dreaming, and unlearning during dreaming. In particular, unlearning of troubling emotional events. Now, my interest in dreaming goes way back. When I was a child, I had a friend, and he came over one day and he brought with him a mask that had a little red light in the corner. He had purchased this thing through some magazine ad that he had seen. And this mask was supposed to trigger lucid dreaming. Lucid dreaming is the experience of dreaming during sleep, but being aware that one is dreaming. And in some cases, being able to direct one's dream activities. So if you're in a lucid dream and you want to fly, for instance, some people report being able to initiate that experience of flying, or to contort themselves into an animal, or to transport themselves to wherever they want within the dream. I tried this device. The way it worked is you put on the mask during a waking state, wide awake, and you'd look at the little light flashing in the corner. And then you'd also wear it when you went to sleep at night. And indeed, while I was asleep, I could see the red light, presumably through my eyelids, although for all I know, I had opened my eyes. I don't know. I was asleep. And then because I was dreaming and I was experiencing something very vivid, I was able to recognize that I was dreaming and then start to direct some of the events within that dream. Now, lucid dreaming occurs in about 20% of people, and in a small percentage of those people, they lucid dream almost every night. So much so that many of them report their sleep not being as restorative as it would be otherwise. Now, all of this is to say that lucid dreaming and dreaming are profound experiences. We tend to feel extremely attached to our dream experience. This may explain the phenomenon of people who have a very intense dream. They need to somehow tell everybody about that dream or tell someone about that dream. I don't really know what that behavior is about, but sometimes we wake up and we feel so attached to what happened in this state that we call dreaming that there seems to be an intense need to share it with other people, presumably to process it and make sense of it. Now, numerous people throughout history have tried to make sense of dreams and in some sort of organized way. The most famous of which, of course, is Sigmund Freud, who talked about symbolic representations in dreams. A lot of that has been kind of debunked, although I think that there's some interest in what the symbols of dreaming are. And this is something that we'll talk about in more depth today, although not Freudian theory in particular. So I think in order to really think about dreams and what to do with them and how to maximize the dream experience for sake of learning and unlearning, the best way to address this is to look at the physiology of sleep, to really address what do we know concretely about sleep. So first of all, as we get sleepy, we tend to shut our eyes, and that's because there are some autonomic centers in the brain, some neurons that control closing of the eyelids when we get sleepy. And then we transition into sleep. And sleep, regardless of how long we sleep, is generally broken up into a series of 90-minute cycles, these ultradian cycles. So early in the night, these 90-minute cycles tend to be comprised more of shallow sleep and slow wave sleep. So stage 1, stage 2, et cetera, and what we call slow wave sleep. I'll go into detail about what all this means in a moment. And we tend to have less so-called REM sleep, REM sleep, which stands for rapid eye movement sleep. And I'll talk about rapid eye movement sleep in detail. So early in the night, a lot more slow wave sleep and less REM. For every 90-minute cycle that we have during a night of sleep, we tend to start having more and more REM sleep. So more of that 90-minute cycle is comprised of REM sleep and less of slow wave sleep. Now, this is true regardless of whether or not you wake up in the middle of the night to use the restroom or your sleep is broken. The more sleep you're getting across the night, the more REM sleep you're going to have. And REM sleep and non-REM, as I'll refer to it, have distinctly different roles in learning and unlearning, and they are responsible for learning and unlearning of distinctly different types of information. And this has enormous implications for learning of motor skills, for unlearning of traumatic events, or for processing emotionally challenging as well as emotionally pleasing events. And as we'll see, one can actually leverage their daytime activities in order to access more slow wave sleep, or non-REM sleep as we'll call it, or more REM sleep, depending on your particular emotional and physical needs. So it's really a remarkable stage of life that we have a lot more control and power over than you might believe. We'll also talk about lucid dreaming. We're also going to talk about hallucinations and how drug-induced hallucinations have a surprising similarity to a lot of dream states, and yet some really important differences. Okay, so let's start by talking about slow-wave sleep or non-REM sleep. Now, I realize that slow-wave sleep and non-REM sleep aren't exactly the same thing. So for you sleep aficionados out there, I am lumping right now. As we say in science, there are lumpers and there are splitters, and I am both. Sometimes I lump, sometimes I split. For sake of clarity and ease of conversation right now, I'm going to be a lumper. So when I say slow-wave sleep, I mean non-REM sleep generally, although I acknowledge there is a distinction. Slow-wave sleep. So slow-wave sleep is characterized by a particular pattern of brain activity in which the brain is metabolically active, but that there's these big sweeping waves of activity that include a lot of the brain. If you want to look this up, there you can find evidence for sweeping of waves of neural activity across association cortex, across big swaths of the brainstem, the so-called pons geniculate occipital pathway. This is brainstem, thalamus, and then cortex, for those of you that are interested, although more of that is going to occur in REM sleep. Now, the interesting thing about slow-wave sleep are the neuromodulators that tend to be associated with it, that are most active and least active during slow-wave sleep. And here's why. To remind you, neuromodulators are these chemicals that act rather slowly, but their main role is to bias particular brain circuits to be active and other brain circuits to not be active. These are like the music playlist. So think of neuromodulators, and these come in the names of acetylcholine, norepinephrine, serotonin, and dopamine. Think of them as suggesting playlists on your audio device. So, classical music is distinctly different in feel and tone and a number of other features from like third wave punk or from hip hop, right? So think of them as biasing toward particular genres of neural circuit activity. Okay, mellow music versus really aggressive fast music, or rhythmic music that includes lyrics versus rhythmic music that doesn't include lyrics. That's more or less the way to think about these neuromodulators, and they are associated as a consequence with certain brain functions. So we know, for instance, and just to review, acetylcholine in waking states is a neuromodulator that tends to amplify the activity of brain circuits associated with focus and attention. Norepinephrine is a neuromodulator that tends to amplify the brain circuits associated with alertness and the desire to move. Serotonin is the neuromodulator that's released and tends to amplify the circuits in the brain and body that are associated with bliss and the desire to remain still. And dopamine is the neuromodulator that's released and is associated with amplification of the neural circuits in the brain and body associated with pursuing goals and pleasure and reward. Okay? So in slow-wave sleep, something really interesting happens. There's essentially no acetylcholine. Acetylcholine production and release and action from the two major sites, which are in the brainstem, which from a nucleus, if it's a parabigeminal nucleus, if you really want to know, or from the forebrain, which is nucleus basalis. And you don't need to know these names, but if you like, that's why I put them out there. Acetylcholine production plummets. It's just almost to zero. And acetylcholine, as I just mentioned, is associated with focus. So you can think of slow-wave sleep as these big sweeping waves of activity through the brain and a kind of distortion of space and time so that we're not really focusing on any one thing. Now, the other molecules that are very active at that time are norepinephrine, which is a little bit surprising because normally in waking states, norepinephrine is going to be associated with a lot of alertness and the desire to move. But there's not a ton of norepinephrine around in slow-wave sleep, but it is around. So there's something associated with the movement circuitry going on in slow-wave sleep. And remember, this is happening mostly at the beginning of the night. Your sleep is dominated by slow-wave sleep. So no acetylcholine, very little norepinephrine, although there is some, and a lot of serotonin. And serotonin, again, is associated with this desire, the sensation of kind of bliss or well-being, but not a lot of movement. And during sleep, you tend not to move. Now, in slow wave sleep, you can move. You're not paralyzed, so you can roll over. If people are going to sleepwalk, typically it's going to be during slow wave sleep. And what studies have shown through some kind of sadistic experiments where people are deprived specifically of slow wave sleep, and that can be done